In example 2, we're going to do the same thing as example 1, only this time you will see exponents with a variable on both sides. So the first thing we want to do is we're looking at our bases, 36 and 6, and we want to get those bases to be the same. So if we look at the 6, can we get 36 to be 6? And yeah, we can. 36 is just 6 to the second power. And then remember, we're multiplying by that x plus 1. And then on the right-hand side, we don't have to change that base since it's already a 6. So we can leave this as 6 to the x plus 6. Then since these bases are the same, I can now set my exponents equal to each other. When I write this one down here, I'm going to distribute that 2 to make it 2x plus 2. So I have 2x plus 2 equal to x plus 6. And then if I want to solve for x, the first thing I would do is subtract x from both sides. That gives me x plus 2 equal to 6. And then what I want to do is subtract 2 from both sides. And I get x is equal to 4. And just like in the last example, you can also check your work. Take the 4, plug it in for the x in both sides, and make sure your answers come out to be the same. If we take a look at letter B, we have 100 to the 2 minus 6x, and 10 to the x squared minus 19x minus 4. Our bases that would be the same. If we look at 10 and 100, these are both multiples of 10, so we should be able to get a base of 10. 100 is 10 to the second, and remember we're multiplying it by that 2 minus 6x. And then since our right-hand side already has a base of 10, we can leave that one as it is. So 10 to the x squared minus 19x minus 4. Now that our bases are the same, they're both 10s, we can take our exponents and set them equal to one another. As we do that, I'm going to distribute again in my first one and take that 2 times 2 and 2 times negative 6 to start. And I get 4 minus 12x equal to x squared minus 19x minus 4. Now this case, instead of having a linear equation like I did over here in letter A, I now have a quadratic equation that I need to solve. To solve quadratic equations, you need to set it equal to 0, and you can either use factoring or the quadratic formula. I will show you both in this problem, and you can choose which way you want to do it. So the first thing I need to do is I need to get my x squared and everything else on one side and set it equal to 0. So I'm going to start by subtracting 4 from both sides. And at the same time, I'm also going to add this 12x, so I can get everything onto one side. So what I end up with is 0 equal to x squared minus 7x minus 8. And from here I have two options. I can look to factor it, or I can use my quadratic formula. Now, if I use the quadratic formula, let me refresh your memory on what that is. Your quadratic formula says x is equal to the opposite of b plus or minus the square root of b squared minus 4. Move this over just a tad bit for us. So that's a minus 4 times a times c, all divided by 2 times a. Or what we can do is we can use factoring. In order to use factoring, though, this must be factorable. So not every quadratic is factorable. So if you try to factor it and it's not working, then you're going to have to go to the quadratic formula. But this is factorable. This will factor into, give me 1 second here, 0 equals x minus 8 times x plus 1. And once we have those factors, we can then take both of these and set them equal to 0. So we get x minus 8 equal to 0, and we can take x plus 1 and set that equal to 0. So we get two answers for this problem. We get x is equal to 8, and we get x is equal to negative 1. Now if we continue on with the quadratic formula, which also will work, you would get x equals the opposite of b. B is the number in front of your x, so the opposite of negative 7 would be positive 7, plus or minus the square root. B squared So again, b is negative 7, so b squared would be 49. Minus 4 times a is the number in front of x squared, which is 1, times c. And c is our constant, which in here is negative 8. And this is all being divided by 2 times a, which is 1. So we get 7 plus or minus the square root. If we look inside that square root, that's 81 divided by 2. So if we take 7 plus or minus the square root of 81 over 2, the square root of 81 is 9. So we get 7 plus or minus 9 over 2. And if we do both of those, we will end up again with 8 or negative 1. As you look at the work involved with the quadratic formula compared to factoring, if you can factor it, it's going to be a lot quicker. So my advice would be to factor. But again, if it's not factorable, then you can go and use that quadratic formula. I'm now going to have you go and do the try this. So if you want to pause it and then check your answer when you're done. If you did the try this correctly, you should have gotten x equal to 9 and x equal to negative 8. Let me know if you have any questions.